Every year, more than 5 billion toothbrushes are produced worldwide, enough to circle the Earth more than 100 times if laid end to end. Yet behind this simple bathroom, essential lies one of the most complex mass production systems on Earth, a process balancing hygiene, chemistry, and precision molding. How does raw petroleum become the smooth handle you grip each morning? And how are thousands of bristles planted with microscopic accuracy in just seconds? Today, we'll step inside high-speed factories that never stop, where molten plastic, nylon fiber, and robotics come together to create the one tool billions rely on to start their day. This is how the toothbrush is made from start to finish. Long before plastic and automation, the toothbrush began as a simple branch. Centuries ago, ancient civilizations used chew sticks, frayed twigs rubbed across the teeth to clean and freshen the mouth. From the Egyptians to the Chinese, hygiene was always a sign of refinement. But it wasn't until the late 1700s that the modern toothbrush took shape, when animal bone handles were drilled by hand, filled with boar bristles, and sold as personal luxuries. 200 years later, that humble invention became one of the most mass-produced items on Earth. Today, the global toothbrush market exceeds 5 billion units annually, generating over $10 billion in revenue every year. Factories in Asia, Europe, and North America operate around the clock, turning out toothbrushes in countless forms: manual, electric, bamboo, and biodegradable, each engineered to balance comfort, precision, and cost. At the heart of this industry lies a paradox. A product designed for personal hygiene must be produced through one of the most industrialized processes ever created. Every curve of the handle, every cluster of bristles is shaped by machines capable of tolerances smaller than a human hair. Each toothbrush may cost less than a cup of coffee, yet its production involves petrochemical refining, polymer synthesis, high-pressure injection molding, micro-drilling, and robotic tufting. From oil fields to factory lines, the journey is global, crossing continents before reaching your bathroom sink. In this massive system, speed equals efficiency. Some factories can produce more than 1 million toothbrushes per day, with bristle tufts inserted at rates exceeding 1,000 per minute. It's a world where hygiene meets precision engineering, and where the smallest detail defines performance. Before we can understand how billions of toothbrushes come to life each year, we must first trace the material at their core, the plastics that give shape, strength, and color to every handle on Earth. Every toothbrush begins its life in a place few ever imagine: the depths of the Earth. Crude oil, drawn from vast underground reservoirs, forms the foundation of nearly all modern plastics. From this thick, dark liquid, refineries extract the molecules that will one day become the handle you hold every morning. In petrochemical plants, crude oil is first heated in towering distillation columns reaching temperatures over 350 degrees Celsius. The vaporized hydrocarbons separate by density, producing a spectrum of fuels and feedstocks, including naphtha, the crucial ingredient for plastic production. Through a process called steam cracking, naphtha is broken down into simpler molecules like ethylene and propylene, the building blocks of modern polymers. Inside massive reactors, these gases undergo polymerization, linking together into long molecular chains. When cooled and solidified, they form polypropylene pellets, small translucent beads that serve as the raw material for toothbrush handles. Each pellet contains thousands of repeating units, giving it both strength and flexibility. Meanwhile, the bristles come from a different polymer family: nylon, first invented in the 1930s. Nylon begins as a combination of adipic acid and hexamethylenidiamine, synthesized under controlled heat and pressure to form tough, elastic fibers. These fibers are cooled, stretched, and cut into precise strands that will later clean our teeth with microscopic accuracy. Before shipment, both polypropylene and nylon are blended with color pigments and stabilizers to enhance appearance and durability. The pellets are then packaged into airtight containers and sent to toothbrush manufacturing plants around the world. What arrives at the factory may look like nothing more than plastic granules, but within them lies decades of chemical innovation, materials designed to withstand daily friction, moisture, and pressure thousands of times over. From oil fields to polymer reactors, each step of this journey transforms invisible molecules into tangible form. And once the pellets arrive at the molding floor, they are ready to take shape, melted, compressed, and sculpted into the ergonomic handles we know by touch, not thought. At full production speed, the toothbrush factory feels alive, a synchronized ballet of heat, color, and motion. Here, raw plastic pellets are transformed into the solid forms that billions of hands will soon hold. Inside the injection molding area, polypropylene pellets are fed into hoppers and carried through steel barrels heated to nearly 250 degrees Celsius. Within seconds, the pellets melt into a viscous flow of liquid polymer. High-speed screws push the molten plastic forward, injecting it through narrow nozzles into multi-cavity steel molds, each designed with microscopic precision. Every mold can produce dozens of handles at once. Hydraulic presses exert tens of tons of pressure, forcing the liquid polymer into every contour, from finger grooves to logo recesses. Water-cooled channels circulate through the mold, solidifying the plastic almost instantly. Within seconds, robotic arms open the press, extract the cooled handles, and transfer them to conveyor lines for trimming and inspection. At this stage, each handle is still plain, smooth, monochrome, and waiting for identity. So begins the multi-shot molding process, where secondary colors and soft-touch rubber grips are added. A second injection machine feeds elastomeric resin into the mold, bonding seamlessly with the original handle. The result is a dual-textured design, a firm inner structure wrapped in a flexible, ergonomic surface. Every dimension is measured to millimeter precision. If even one mold cavity deviates by a fraction of a degree, thousands of defective parts could result. To prevent this, laser alignment systems and temperature sensors constantly monitor each cycle, ensuring uniformity across every batch. Once molded, the handles travel down automated lines to be cooled, polished, and embossed with brand markings or model codes. Some are even ultrasonically welded with small reinforcements or grip inserts for electric toothbrushes. By the end of this stage, the once molten polymer has become a durable, ergonomic structure, perfectly balanced for comfort, strength, and control. And while each handle looks complete, it remains only half the story. Next, the toothbrush will gain its defining feature, the thousands of fine bristles that give it purpose. The molded handles now move toward the section where the toothbrush truly takes shape. A place where silence gives way to motion and machinery performs work finer than the human hand. Inside the tufting hall, hundreds of automated lines operate in perfect rhythm. Here, every handle is transformed into a tool of precision cleaning through a process called anchor tufting. The first step is micro-drilling. Rotating steel bits pierce the head of each handle, creating up to 50 tiny holes in perfect alignment. Each hole must be smooth, clean, and exactly the same depth. Even a microscopic variation can alter how the bristles bend during brushing. From there, the process becomes a dance of speed and synchronization. Fine strands of nylon bristle, pre-cut into uniform lengths, are loaded into feeding units above each machine. Mechanical pincers grab a small cluster of bristles, Fold them in half around a metal anchor wire and insert the tuft into the drilled hole with a sharp, controlled motion. In a single second, this sequence repeats dozens of times, so precise that one machine can implant over 1,000 tufts per minute. Once every hole is filled, the toothbrush head bristles outward like an untamed field of nylon. The next stage is trimming, where rotating blades cut the bristles into their final shapes: flat, domed, or wave-patterned, depending on the design. Laser sensors check the profile of each brush to ensure perfect height uniformity, often measured in hundredths of a millimeter. Then comes tapering, the stage that defines comfort. Each bristle tip is polished and thinned through controlled heat or micro-abrasion, giving the ends a rounded finish gentle enough for gums but strong enough to remove plaque. Every finished head undergoes mechanical flex tests, simulating thousands of brushing cycles to confirm durability and consistency. Only after passing these tests are the toothbrushes moved to final assembly, where color bands, rubber tongue cleaners, and brand emblems are attached. By now, the transformation is nearly complete, a fusion of chemistry, precision robotics, and microengineering that turns ordinary nylon and plastic into a tool we use every single day, often without a second thought. With every bristle in place and every handle complete, the toothbrush enters the final phase. A stage defined not by creation, but by verification. Here, nothing is left to chance. Each production batch undergoes a series of quality control tests that determine whether it will reach the market or be recycled back into raw material. Automated cameras scan every toothbrush at high speed, checking for uneven bristle cuts, missing tufts, or surface defects. Precision sensors measure handle alignment and color accuracy, ensuring that even mass-produced items meet microscopic standards of consistency. From there, the toothbrushes move to the tensile testing station. Mechanical arms pull at random tufts to test anchoring strength. Each must withstand a force of several newtons without loosening. Other machines simulate brushing, pressing the heads against artificial teeth in rhythmic cycles that mimic months of real-world use. These endurance tests confirm that each toothbrush can survive tens of thousands of strokes without losing integrity. Once approved, the brushes are sent through the sterilization chamber. Here, ultraviolet light and pressurized steam eliminate any trace of bacteria, oil, or dust left from manufacturing. In some facilities, oxygen plasma or ozone sterilization is used, modern, chemical-free methods that guarantee complete hygiene without residue. The sterilized brushes then travel along conveyors to automated packaging lines. Transparent wrappers are heat-sealed within milliseconds, locking in cleanliness. Each product receives a printed barcode, batch number, and expiry date, critical for traceability across global markets. For electric toothbrush heads, sterile chambers handle every component separately, assembling and sealing them with robotic precision. Finally, the packaged toothbrushes are grouped, boxed, and stacked onto pallets bound for distribution centers. From there, fleets of trucks and cargo containers carry them across continents, to supermarkets, pharmacies, and households in nearly every country on Earth. In a matter of weeks, the same toothbrush that began as oil beneath the ground travels thousands of miles, ending up on a store shelf, ready to become part of someone's morning routine. From oil wells and polymer reactors to high-speed molding lines and microscopic bristle machines, the toothbrush's journey reveals the complexity hidden behind simplicity. Every curve, every strand, every polished surface is the result of engineering precision designed to serve a daily ritual we often overlook. In less than a century, the toothbrush has evolved from carved bone and boar bristles into a symbol of modern hygiene, a tool that touches billions of lives every morning and night. It connects chemistry to health, design to science, and personal care to global manufacturing. Behind each one lies an entire ecosystem of workers, machines, and materials moving in perfect synchronization. A quiet orchestra of technology built for a single purpose: cleanliness. Its value isn't measured by luxury or rarity, but by reliability. By the trust that, in every bathroom around the world, this small object will perform its duty flawlessly. And while the world races forward with smart devices and innovation, the toothbrush remains one of humanity's most enduring designs, a reminder that even the simplest tools can embody the height of precision and purpose. This is how the toothbrush is made, from start to finish.